All right, next up is scenario analysis. So scenario analysis is different than sensitivity, most specifically in the scale of the change. So when we were doing sensitivity on revenue, for example, we changed revenue by $1 and then divided by the change in revenue to get that change in NPV per dollar. Scenario would not change revenue by $1. It might change revenue by $3 billion, right? And then we look at, given a massive change, what is the massive change in NPV? And then we might like to make sure that NPV is still positive. And the kind of scenarios we can imagine are, the kind of things you might role play out if you were in a war room situation. So we are a software developer, and the scenario is our competitor came out with a rival product that is going to launch in 12 months. And so in order to stay competitive, we have to go crazy overtime for everybody, and labor costs shoot up, and so fixed costs go through the roof, but variable costs stay the same. A different example would be if we're an insurance company, maybe we do different kind of disaster scenarios where we say, well, what if we have a heavy hurricane season? Or what if interest rates fall dramatically? Insurance companies depend heavily on interest rates to fund future claims as they turn premiums into investable funds to pay out later. And so there's all sorts of scenarios we can dream up. And the idea of a scenario in an NPV is to translate the scenarios into assumptions about the underlying data in an NPV calculation. And so examples for Stuart could be a heavy cold season. So that's good for our product, but it also is expensive for us because we have lots of missing labor and lower productivity. So maybe we need to hire more workers to make up for so many people being out sick. Or maybe the cold season is light, and so we don't really get any additional productivity because people are just fine, but now our sales are low. So there's different ones we could do. So the example we'll do is the heavy cold season one. So we'll say revenues increase 30%. So we have significantly more revenue than we were expecting. Lots of demand for our product. But because of the difficulty of maintaining an able-bodied workforce, our variable costs will increase to 4/7. And this is the kind of thing you can do a scenario, is you can have multiple effects across the pro forma and just look at the overall effect. So we're going to increase revenue by 30% and increase variable cost to 4/7. So if we flip back over to our, right, so this is our adjusted. We adjusted it by $1, and that was a sensitivity analysis. So we're going to do a scenario now, right? So our scenario was some pretty significant changes. So that 7,000 was going to increase by 30%. So that would be a total of 130%. 130% of what it was. So that's $9,100. But now in here, rather than so we used to be at 3/7, so we're going to add 1/7 to make it 4/7. And that's consistent with the slides. We have 9,100 and 5,200. And so we get a new NPV number. And basically NPV is mostly unchanged. Right? We have more revenue, but we have more costs, right? Revenue went up by 2,100. Costs went up by 2,200. Some of that is defrayed by tax. And so we end up with, because we pay less tax because we have smaller earnings, so we end up with less money but not by a large amount. And so that would be right. So this here, the bold underline here, that would be our heavy cold season scenario, right, where we have the lower NPV slightly. And so yeah, and we could really be anything, right? We could do a scenario where fixed costs increase, and we could do a scenario where the taxes maybe jump to 44% all at once, right? So we have a perfect storm of a bunch of stuff happening. We're still very profitable. And so if we get to this point, we would still definitely do this project, even with all this stuff going on. Okay, so then you give them different labels, have different effects, and then go for it. All right, so that's how scenarios work. Okay, sorry. So we're just about to you try it. So one thing I need to point out is often the way scenarios are structured is we do what's called maybe a best case scenario and a worst case scenario. And so a best case scenario is say, okay, all the wiggle room we have in our data, let's make all the good numbers bigger and all the bad numbers smaller, right? So revenue, let's just say that all of our inputs have a 10% variability, right? It could be up or down 10%. So you say, okay, everything good in the problem gets multiplied by 1.1. So revenue goes up by 1.1. And then everything bad in the problem gets multiplied by 0.9. So we say variable costs are 90% of what they were in the original problem. Fixed costs are 90% of what they were. Taxes are 90% of what they were. Something like that. Whatever numbers have wiggle room. In the best case scenario, we will assume the bad ones are lower by the maximum amount and the good ones are higher by the maximum amount. Naturally, in the worst case scenario, right, we would say revenue is only 90% of what it should be. Variable costs 110% of what they should be. Fixed costs 110% of what they should be, and so on. And that's a pretty typical way to do a scenario analysis, is to say, well, what's the best case scenario? What's the worst case scenario? And obviously, if you get a positive NPV in the worst case scenario, that's a really good sign, right? If you get an NPV that's negative in the worst case scenario, but that's very small negative compared to a very, very large positive best case scenario, then you can say, well, I mean, there's a chance we can lose money on this, but the chance of getting a big home run is worth the small cost of a strikeout. But if the worst case scenario looks really bad and the best case scenario looks okay, even if the project's NPV positive, we might choose not to do it because it's just too risky in the event that our numbers don't come in like we'd expect. So that's the kind of scenario often you'll be asked to consider. Mostly because it's a way to think about scenarios broadly across a lot of different classes of problems. Otherwise, you need to do industry-specific and market-specific kind of scenarios, which is usually more than could be constructively asked on a homework question. So go ahead and try the scenario analysis problem on Blackboard. Again, it's optional, but it's a good check to make sure you're following along, and then and pause the movie, and when we come back, we'll take a look at break-even analysis. Okay, break-even analysis is, as it sounds, right, we're asking what sort of requirements do we have to, find the break-even number for a given project. And actually, and there's a couple different kinds of break even. So we have accounting break even, where we are saying what do we need to get to achieve a net income of 0, right? So accounting earnings for the year for the year in question are zeroed out. That's accounting break even. That's going to be different than cash break even. Why? Because accounting break even includes lots of non-cash charges, in particular depreciation, right? So if we are not counting depreciation, then we can actually come in with a lower number and get to break even. But if you think about it, right, if we're not counting depreciation, that means if we're operating at break even without depreciation for a while, at some point we're going to have to replace the machine, right? And we won't have any money to replace it with, and so we'll be in trouble. So cash break even really only works for short-term kinds of thinking. Accounting break even should be better for the long term, although we're not adding value to the firm. Naturally, the most important one is financial break even, where we're finding the required input to make NPV 0. Okay, so even for a project that already exists, we can think about what are the different scenarios, what are the different the different break-even numbers in terms of revenue for our project. So if we do break-even for Stuart, we can think about the 3 different types of break-even. The easiest way to do break-even analysis is to use Excel Solver. I mean, you can work backwards from, so you can take an income statement and say, all right, net income is 0, and then do algebra working backwards, right? You can say, oh, well, if net income is 0, that means EBIT must also be 0, right? And tax is 0. And then if EBIT is 0, that would mean EBITDA must be exactly equal to depreciation, and so on. So you can do this with algebra. It's, like, I guess, a bottom-up approach where you start with the break-even you want and work up. But much easier is to do an Excel Solver approach. So I'm going to have Solver here, and let's do accounting break-even on our baseline model. So we want, right, there's now our labels are visible here. So we want net profit to be 0 for accounting break-even. So I'm going to say, well, let's set this guy to be a value of 0, and we're going to do it by changing revenue. So usually when we think about break-even, we want to know break-even revenue. How many sales have to come in for this thing to work? And then we'll go ahead and fire it up here. Solver found a solution, and we've got our 3850, which matches our accounting break-even here from the slides. Right? So here's our answer up here. Right? This is the, and actually you can tell it's 3849.9999999 whatever. It's because Solver quits when it gets close enough. Right? This is close enough to 0 that it's happy. So this is our break-even revenue, the revenue we would need to come in at 0 earnings every year for all 4 years. Naturally, right, this produces a negative NPV. Why? Because, let's see, yeah, but it's a negative NPV because if we earn 0 over and over and over again, we are going to have $1,600 of cash flow, $400 each year for 4 years, but you'd pay $1,600 to get $400 4 times. Time value of money, that's losing out. And so we have a negative NPV. Even easier to achieve is cash flow break even. So let's do that. So we'll target cash flow of 0 instead of NPV, or instead of net income of 0. Go ahead and solve it. And now you can see, right, we've got a smaller number of required revenue, and we're losing exactly $1,600 in net present value. Because, right, we have no cash at all ever, so the $1,600 we put in is just lost. Best would be the 0 NPV break even by changing the revenue. So of course we get 0 NPV, and now we have a break-even revenue number that gets us to 0 NPV. So as long as we have $4.1 billion of sales, we will be in positive NPV territory. And then we would have to ask ourselves, honestly, all right, our $7 billion projection, how likely is it that we're above 4.1? Chances are we're pretty confident we can make 4.1 billion if we're predicting 7. But it depends on the actual project, whether or not this is a good idea, or how variable the revenue estimates are. So so that is break-even analysis. So there's I think there's a break-even analysis. You try it. So go ahead and give it a shot, and we'll end this segment of the video. And for the next segment, we will talk about operating leverage, which is like a sensitivity analysis, but has a special character to it. So yeah, go ahead and give this problem a try on the course page, and then come back for the next part.